Section 8.2, Rational Exponents. So what word should come to mind when you see the word rational? The word that should come to mind is fractions. So we're going to have fractional exponents. Well, fractional exponents can be rewritten as radicals, and radicals can be rewritten as fractional exponents. So how can we go back and forth between the two? Well, in a fractional exponent form, the a is considered the base, the 1 is the numerator, and the n is the denominator. So if we had fractional exponents, we have a base, we have a numerator, and we have a denominator. But in radical form, the base is the radicand, and the numerator will be the power, and the denominator will be the index. So let's see how this looks. A to the 1 over n. So a is raised to the power of 1 over n. A is the base, 1's the numerator, n's the denominator. So in radical form, the a is the radicand. So that's what goes underneath the radical. The 1 is the power, so it's a raised to the first power, and the index is an n. So it's going to look like the nth root of a. We don't have to put the 1 because the 1 is understood to be there. So the denominator is the index, the numerator is the power, and the base is the radicand. So let's use this information to answer the next questions. Rewrite using radicals, then simplify if possible. Assume all variables represent non-negative values again. So number 1, 36 to the 1/2. 36 is going to be the radicand, so that goes what's underneath the radical. What's the index? It's the index of a 2. It's understood to be there, but I'll put it there for now. And what's the power? To the first power, so I could raise 36 to the first power, but that doesn't change it. So we're just looking for the square root of 36, and the square root of 36 is 6. So let's look at number 2. 16 to the 1/4. 16 is the radicand, 1 is the power, 4 is the index. So it's the 4th root of 16. So what number can I multiply 4 times and get 16? That would be 2, because 2 times 2 times 2 times 2 is 16. Number 3. In parentheses, negative 125 raised to the 1/3 power. So the index is a 3. The radicand is negative 125, and it's all raised to the first power. Is there a number that I can multiply 3 times and get negative 125? Yes, the answer would be negative 5, because negative 5 times negative 5 times negative 5 is negative 125. Number 4, 49 to the 1/2. Again, the 2 is the index, so it's the square root of 49. I'm not going to put a 2 there because it's understood to be there. And the 1 is also understood to be. So what's the square root of 49? The square root of 49 is 7. So just remember the radicand is the base, the power is the numerator, and the denominator is the index. So what happens if our numerator is not a 1 anymore? So rewriting a rational exponent with a numerator other than 1. So a raised to the m over n. Well, a is still the base, which is the radicand. M is still the power, which is the numerator, and n is still the index, which is the denominator. So to look at that, we see that a is still the base, we call it the radicand. The numerator is still the power, it's not going to be 1 anymore, and the denominator is still the index. So when we rewrite a to the m over n, it's still the index with an n raised to the mth power. But the great thing about this is that you can actually take the power on the outside instead. So we're going to have the index of n, so the nth root of a, all raised to the m power. Put that power on the outside and it'll make your life a little bit easier when you're trying to simplify. Rewrite using radicals, then simplify if possible. So number 1, we have 8 raised to the 4/3. The 4 is the power, the 3 is the index. So rewriting this is the cubed root of 8, all raised to the 4th power. I like to put the power on the outside because then I can simplify a little bit easier. What's the cubed root of 8? Well, what number can you multiply 3 times and get 8, which is 2, and then we need to raise it to the 4th power. So 2 to the 4th power is 16. So 8 to the 4/3 is 16. Looking at number 2, we have 9 raised to the 3/2. 3 is the power, 2 is the index. So this is the square root of 9, all raised to the 3rd power. The square root of 9 is 3, and then we need to cube it. So 3 times 3 times 3 is 27. Now be careful on the next problem. Number 3 has negative 27 raised to the 2/3. Does the negative go inside the radical or outside the radical? If it was in parentheses, then negative would be stuck with the 27, so it would go under the radical. But with the way it's written, that negative actually stays out in front. So the negative is outside the radical, then we get the cube root of 27, and only that is raised to the square power, not the negative. So my answer will definitely stay negative. So the cube root of 27 is 3, and then I need to square the 3 and I get a 9, but the negative's on the outside, so my answer is negative 9. Again, if there were parentheses, then that negative would be being raised to that power. Since it's not in parentheses, the negative just stays out in front. Number 4, 81 to the 3/4. The index is a 4, so it's a 4th root of 81, and the power is a 3, so I'll raise it to the 3rd power. What number can you multiply 4 times and get 81? Well, that's 3, because 3 times 3 times 3 times 3 is 81. Then I need to cube it, so 3 cubed is 27, because 3 times 3 times 3 is 27. Now let's look at number 5. 9 to the negative 1/2. Negative exponents. We learned about these earlier. They do not make things negative. They move things. So 9 to the negative 1/2 needs to go to the bottom into the denominator, and we get 1 over 9 to the positive 1/2. Now we can rewrite it, but do not rewrite that until you've gotten rid of your negative exponent. So 9 to the 1/2, we have a power 1 and an index of 2, so we just get the square root of 9. And the square root of 9 is 3, so my answer is 1 over 3, because the negative moved it to the denominator. For number 6, 16 over 49, all raised to the negative 1/2 power. So the power rule says distribute that power to every power. So we're going to have 16 to the negative 1/2, all over 49 to the negative 1/2. Again, negative exponents move things. So 16 to the 1/2 is going to go down, and 49 to the 1/2 is going to go up, so now my powers are positive. So then I will rewrite them in radical form. So 49 to the 1/2 has an index of 2, so it's the square root of 49. And 16 to the 1/2 says you have an index of 2, so it's the square root of 16. And the square root of 49 is 7, and the square root of 16 is 4, so my answer is 7 over 4. Number 4, again we have a negative exponent, so be very careful. 4 to the negative 3/2, we first need to rewrite that as 1 over 4 to the positive 3/2. Now we're going to rewrite that in radical form. The power is a 3, the index is a 2, so it's the square root of 4 raised to the 3rd power. And what's the square root of 4? It's 2, then we have to raise it to the 3rd power, so we get 1 over 8. Lastly, number 8, 25 to the 1/2 plus 100 to the 1/2. They're not negative exponents, so we can go ahead and start rewriting them in radical form. Index is a 2, so it's the square root of 25, plus index is a 2 again, so it's the square root of 100. Square root of 25 is 5, square root of 100 is 10, and 5 plus 10 is 15. Rewrite in exponential form. So now we're going to go the opposite direction. We have a radical, and we want to rewrite it in a fractional form. So 33 has a power of 1. So 33 has a power 1 and an index of an 8. So in exponential form, it's just 33 to the 1/8. Number 2, we have the 5th root of 7 all raised to the 3rd power. Again, we have power over index, so we have 7 as a radicand, and that becomes my base. The power is 3, and the index is 5, so it's 7 to the 3/5. So just remember that radicals can be written as fractional exponents, and fractional exponents can be rewritten as radicals. Alright, so be careful with what the directions say next. Use the rules of exponents. It doesn't say anything about radicals. We want to use rules of exponents to simplify. Write the answer with positive exponents. Assume that all variables represent positive values. So we're going to not want to change these into radical form. Everything says use rules of exponents, rewrite with positive exponents, so don't change it into radicals. So number 1, we have x to the 3/4 times x to the 5/4. When we're multiplying, what do we do to powers? We add them. So we have x to the 3/4 plus 5/4. We already have a common denominator, which gives us 8/4, and 8 divided by 4 is 2. So our answer is x squared. Number 2, this is that power to power rule. So what do we do with the powers? We actually multiply them. So a to the 2/3 times 3/4. We do not find common denominator when we're multiplying. So either multiply straight across or reduce. If I multiply straight across, I get 6 over 12, and 6 over 12 reduces to 1 over 2. It did not say anything about changing into radicals, so leave it with fractional exponents. Number 3, parentheses, x to the 3/4, y to the 1/8 times z to the 5/6, all raised to the 4/5 power. What do we do when there's power on the outside? That's a power to power rule, so we distribute it to every power, making it multiplication. So when we do so, we get x to the 3/4 times 4/5, y to the 1/8 times 4/5, and z to the 5/6 times 4/5. If you want to multiply straight across and then reduce, you can, or you can cross cancel. I'll go ahead and multiply straight across and then reduce. 3 times 4 is 12, and 4 times 5 is 20, so we get x to the 12 over 20. Multiplying with the y exponents, 1 times 4 is 4, and 8 times 5 is 40, so we get y to the 4 over 40. Lastly, we get z raised to the 20 over 30 when we multiply straight across. Sometimes I draw lines through my z's because sometimes my z's look like 2's, so I just want to make sure my z is really a z. Now I'll go ahead and reduce 12 over 20. 12 over 20 reduces to 3 over 5. And with the y, 4 over 40 reduces to 1 over 10. And with the z, 20 over 30 reduces to 2 over 3. So my final answer is x to the 3/5, y to the 1/10, times z to the 2/3. Number 4, y to the 5/4 all raised to the 2/5 power, all over y to the 1/4 all raised to the 4/3 power. So again, we have a power to power rule. So we'll just distribute the power to every power. We get y to the 10 over 20 when we multiply those fractions, and y to the 4 over 12 when we multiply those fractions together. Now let's go ahead and reduce. 10 over 20 reduces to 1/2, so we get y to the 1/2, and 4/12 reduces to 1/3, so we get y to the 1/3. Some students think they're done. However, we have y's on top and bottom, and when we're dividing, what do we do to exponents? We need to subtract. So we get y to the 1/2 minus 1/3. Well, when we're subtracting, we have to find a common denominator, which is a 6. So both my denominators need to become a 6, so my numerators will change too. This one gets multiplied by 3, so 3 times 1 is 3. This one needs to be multiplied by 2, so 1 times 2 is 2. So we end up with y to the 1/6 as my final answer. Number 5. First thing I would do is I would get rid of negative exponents just to be on the safe side. You can certainly work with negative exponents, but it does take a little more thinking sometimes as you go through these problems. So I'm going to take the n to the negative 4/5 down. So number 5 has n to the 2/3 times n to the negative 4/5. So n to the 2/3 is going to stay, but n to the 4/5 will need to go down. And now my power becomes positive. So when I'm dividing, I subtract exponents, so I get n to the 2/3 minus 4/5. At this point, I do need to find a common denominator, and my common denominator is 15. So I would have needed to multiply this denominator by 5, so 5 times 2 is 10. This denominator needs to be multiplied by 3, so 4 times 3 is 12. When I subtract those, I get n to the negative 2 over 15. The directions say don't leave negative exponents negative, so I need to bring that down to the denominator and to get 1 over n to the 2/15. Number 6. parentheses, 5p to the 1/9 times 3p to the 1/9. Well, we're just multiplying. So multiply 5 times 3, we get 15. But when we multiply, we add power. So we have 1/9 plus 4/9. We already have a common denominator, which is nice, so the 15 will stay, and we get p to the 5/9. That cannot be reduced. It is a positive exponent, so we are done. Number 7. X to the 5/8 divided by x to the 1/4. Well, when we're dividing, we subtract exponents. So we get x to the 5/8 minus 1/4. Because we are subtracting, we need to find a common denominator. The first number 4 and 8 can all go into is 8. So the 5 is going to stay as is, but we would have to multiply the 4 by 2, so 1 times 2 is 2. So when we subtract that, 5/8 minus 2/8 is x to the 3/8. Number 8, again, we just have the power rule with a power on the outside, which means we multiply powers. Multiplying straight across, on number 8, we have m to the 3/2 all raised to the 2/5 power. So multiplying straight across, 3 times 2 is 6, and 2 times 5 is 10. So just reducing 6/10, that reduces by 2, so we end up with m to the 3/5. It says represent as a radical with a smaller root index. Number 1 has the 6th root of y squared z to the 4th. In radical form, we're stuck. There's nothing we can do with that. Power divided by index does not work because we don't have enough. But what if we change it into fractional form? So we end up with y to the 2/6 times z to the 4/6. Can we reduce those fractions now? Sure. 2/6 reduces to 1/3, and 4/6 reduces to 2/3. So now we have a smaller index. Our denominator is our index, which is the cubed root. So we can have the cubed root of y to the 1st power, z to the 2nd power. So with a smaller root index, that's the cubed root of yz squared. So looking at number 2, we have the 6th root of 25. Well, putting that into fraction form just gives us 25 to the 1/6. That doesn't help us at all because 1/6 cannot be reduced. So let's think about rewriting 25. Well, 25 is really 5 squared. So this would be the 6th root of 5 squared. Now rewriting that, that is 5 to the 2/6. And we reduce that, we get 5 to the 1/3. So as a smaller root index, this would be the cubed root of 5. So this is just trying to get you to realize that if you're stuck in one form, change it into another form to see if you can simplify in the other form. Perform the indicated operation. Number 1 says the 4th root of x times the cubed root of x squared. Well, we're going to see in the next section that to be able to multiply, we have to have the same index, and we do not have the same index here. So let's go ahead and put it in rational form to see if we could use rules of exponents. So the 4th root of x is really x to the 1/4 times the cubed root of x squared is x to the 2/3. So in rational exponent form, we see that we can go ahead and put those together as long as we find a common denominator. When we're multiplying, we add powers, and the first denominator that 4 and 3 can all go into is 12. So what does my numerator need to be multiplied by? Well, the first one needs to be multiplied by 3, so we get 3/12. And the second one needs to be multiplied by 4, so we end up with 8/12. So we had to find a common denominator. Adding those together, we get x to the 11/12. But it did say perform the indicated operation, which means we want it to be in radical form. Well, 11 is the power and 12 is the index. So we go back into radical form, would be the 12th root of x to the 11th. Number 2, we have the 5th root of x to the 4th times the cubed root of x squared. Again, we're stuck in this form because we can't multiply without the same index. So let's put it into rational exponents. This would be x to the 4/5 times x to the 2/3. Now with rational exponents, we can use exponent rules that says when we're multiplying, we add powers. So x to the 4/5 plus 2/3. So therefore, we'll need to find a common denominator. The first number 5 and 3 can both go into is 15, so I need both of my denominators to become a 15. I get x to the 22 over 15. Back in radical form, the 20 is the power and the 15 is the index. So this is the 15th root of x to the
22nd.
What I want you to realize is now the power on the inside is bigger than the index, but it doesn't come out evenly. So put a dot, 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 because that's what we're going to learn what to do in the next section. So we really should go farther with that one, but we're not going to do that quite yet. So number 1, write as a single radical. Last little problem of what do we do if we're stuck in one form? Well, we really are stuck in this form because the cubed root of the fifth root of m doesn't really allow us to go anywhere. But if we rewrite this in radical form, let's think about what the fifth root of m looks like. That looks like m to the 1/5. Well, if that's underneath the cubed root, so now we have the cubed root of m to the 1/5, how can we rewrite a cubed root? Well, the cubed root in rational exponent form is a 1/3. So really, the cubed root of the fifth root of m can be rewritten as m to the 1/5 all raised to the 1/3 power. And when we are having a power to power rule, we multiply our powers. So 1 times 1 is 1 and 5 times 3 is 15 because we could just multiply straight across. Putting this back into radical form, the index is a 15 and my power is 1. So this is a 15th root of m. So anytime you're stuck in one form, try and change it into a different form.